Recall, to find the limit of a rational function plus minus infinity, if you recall, we divide the denominator and the numerator by x to the highest power of x in the denominator. This technique can be extended to more cases. For example, a case when we have radicals. Let's try to evaluate this limit. We are going again to use the same technique. You can see that we have to divide everything by x to the power of 2 because the highest power of x in the denominator is 2. The thing is what to do with the radical. You have now to notice that x to the power of 2 is x to the power of 4 in the radical, which means that outside of the radical we are going to divide by x to the power of 2, but in the radical we are going to divide everything by x to the 4. Now we are going to simplify the algebra. And we know that the limit of this and this is 0. And we get just radical of 4 over 1, which is 2. Example. Be careful now. We have to divide everything by x because the highest power of x in the denominator is 1. And we also have to notice, and we will start noticing that it is important if x is positive or negative. When x approaches infinity, x is obviously positive. It means that in the square root, we have to divide everything by x to the power of 2. Simplify the algebra. We know that this and this, both of these, approaching 0 when x approaches infinity. And we get that. We simplify more, and we get that this is the limit of 2x when x approaches infinity, which is obviously infinity. Note that in general, the square root of x to the power of 2 is x in absolute value. In this case, we didn't bother with this too much because, again, when x is positive, then the absolute value of x is x, and we get directly that x equals the square root of x to the power of 2. Be careful. When x is less than 0 and n is odd, we get that the square root of x to the 2n is what? X is negative, so the square root of x to the 2n is absolute value of x, but the negative of square root of x to the 2n is really x to the n. This is always true. If you noticed, if x is negative, this is negative, and this is positive, but because you have the minus, they are the same. Which means that we are going to have really to deal with much more difficulty if we are taking the limit when x approaches negative infinity in those cases. Because if n is odd and x approaches negative infinity, then we get actually that x to the n equals negative of the square root of x to the 2n. For example, let's see this case. The square root of x to the power of 2 is always absolute value of x. When x is positive, it is x, but when x is negative, it's negative x. It means that at infinity, x is positive. So, I get that the square root of x to the power of 2 is x, so I can divide as we did before. In the square root, I divide everything by x to the power of 2, and outside the square root, I divide everything by x. But the problematic part is definitely at minus infinity. At minus infinity, x is less than 0. It means that the square root of x to the power of 2 is not x anymore, but it's negative x. Because, again, the square root of x to the power of 2 is absolute value of x, but absolute value of x when x is negative, it's negative x. This is complicated because now it means that if inside the radical I divide everything by x to the power of 2, outside I have to divide by negative x. We can really summarize this and show that when the limit is x approaches infinity, those limits are easy. But when x approaches negative infinity, you have to be very careful. Let's do an example. Let's evaluate this limit, but now x approaches negative infinity. We have to divide everything by x. But at negative infinity, x is less than 0. It means that actually, if inside the square root I want to divide everything by x to the power of 2, then outside I have to divide not by x, but to divide by negative x. And I get that. We are doing now the algebra. It's the fun part now. And we get that, which is negative 2. Example. Pay attention, now the limit is when x approaches negative infinity. We will divide by x to the power of 2 because the highest power of x in the denominator is 2. Now, at negative infinity, we pay attention that x is less than 0. But we still really don't care because x to the power of 2 is still the square root of x to the 4. Because x to the power of 2 is positive. We divide in the square root by x to the 4 and outside the square root by x to the 2. We get that. Simplify the algebra. Take the limits of this. And we just get 2. You probably wonder why I showed you that when x approaches negative infinity, I have actually to divide outside the radical by negative something. The reason that this is not going to be applied here is because we don't have this case in this example, because we have that n equals 2. It is an even. So if n is odd, and you get a situation of x to the power of n when n is odd, like x cubed, x to the power of 5, then you have to do this complication with dividing in the radical differently than outside the radical. But here, n is 2, and 2 is an even number. Division by the largest amount in the denominator can also be applied to exponential functions at infinity. Only at infinity, please remember. This is true that the limit of x approaches infinity of e to the power of a number, a positive number, times x equals infinity. Now we're ready to do some examples. And here's the first one. You can divide everything by 3e to the 2x or by e to the 2x. I will always leave this constant alone. Just divide everything. Now use algebra to cancel out. A lot of the things here are going to be cancelled out. I get 1 over 3 minus 4 over e to the 2x. What is the limit of 4 over e to the 2x? This is a huge number. I'm talking about e to the 2x. So it's 4, it's a constant over something huge. Obviously approaches 0. And I get 1 over 3. Example. Here again, the largest amount is e to the 2x. So I'm dividing everything by e to the 2x. Cancel out. E to the 3x over e to the 2x, please remember this is e to the power of x. This is 1 over huge, another 1 over huge. And we get that. Obviously, nobody cares about the over 3 because e to the x is huge. You can divide it by 3, it's still huge. It is infinity.